In sac130, problem number 1, we're asked to find the intensity of sound required to produce an intensity level of 90 decibels. So we're asked to find the intensity I associated with a given intensity level beta, also known as loudness. So we'll use that equation that relates the loudness and the intensity, namely beta is 10 decibels times the log base 10 of I, the intensity, divided by I sub 0, the known value of the intensity of sound at the threshold of human hearing. I'm going to go ahead and define beta sub 0 to be exactly the 10 decibels, just so that I'm not writing that number 10 decibels over and over. I prefer to write a symbol instead. So beta 0 is defined to be 10 decibels, in which case our relation between beta and I looks like this. Beta is the beta 0, that 10 decibels, times the log of I over IO. I've just replaced 10 decibels with a symbol beta 0. And then I'm going to go ahead and solve for I. I get started by dividing both sides by beta 0. I is on the right-hand side of the equation. I'm trying to get it all by itself, and it's supposed to wind up on the left-hand side of the equation. In fact, I'll go ahead and get it over to the left. I'll just switch sides in this next step. So I got the log I over IO is just beta over beta 0. And now I've got the log of something on the left, and that's all I have on the left. There's nothing multiplying the log. It's just the log of something all by itself on the left. And I need to get rid of that log because I'm trying to get the I all by itself. To get rid of the log, I apply the inverse function to both sides of the equation. That gets rid of the log and it still maintains the equality. And the inverse function to the log base 10 function is what I call the 10 to the function. In other words, I have to raise 10 to what is on each side of the equation. 10 to the log of something is just that something, so I got the I over IO, and then 10 to what's on the right is 10 to what's on the right. I just gotta write that down. And now I've just about got I all by itself, the intensity I'm trying to solve for. The last step is just to multiply both sides by I0, and I got I is I0 times 10 to the beta over beta 0. I've completed the algebraic solution of the problem. Now I just have to substitute values with units and solve. The I is I sub 0 is the threshold intensity. It's the intensity of sound at the threshold of human hearing. A known value, you can look it up in a book. In this case, it was given in the problem. And then the beta, well, we're trying to find the, and we do have units for that I0. It's 1 times 10 to the minus 12 watts per meter squared. Then the beta, well, they said find the intensity for the case where beta is 90 decibels. That was given in the problem. So we substituted in the value 90 decibels for the beta, and we go ahead and evaluate that. Now, in this case, it's particularly easy to evaluate. We don't even need the calculator. The decibels cancel out in that exponent of the 10, and 90 divided by 10 is just 9. Keep in mind the 10 decibels in the denominator over here is an exact value. Don't use sig figs for that. It's an exact value. So we actually have 9 known to 3 sig figs. So we got 10 to the 9th. We're multiplying that times 1 times 10 to the minus 12. When you multiply different powers of the same thing, you just have to add the powers. And so we wind up with 10 to the minus 12 times 10 to the 9th is going to be 10 to the minus 3. So I is just 1.00 times 10 to the minus 3 watts per meter squared.